Okay, now students, as you have already studied about phase and phase difference, now we are going to move to the next topic, which is wave velocity and particle velocity. As explained earlier also, wave velocity and particle velocity are different. Wave velocity is the velocity with which a wave travels or propagates in the medium. So this will give you wave velocity. But particle velocity is the velocity with which the particle it vibrates about its mean position. So there are two types of velocity in waves, wave velocity and particle velocity. Now let us first of all discuss wave velocity. So in you have found displacement equation for plane progressive harmonic wave equals to a sine omega t minus kx. Now, wave velocity v is defined as, always remember this, wave velocity v is always defined as coefficient of t upon coefficient of x. Now, what is the coefficient of t? Time. As I've already told you that this displacement of the particle is a function of x and t. X is the position and t is the time. So wave velocity is a ratio of coefficient of t upon coefficient of x. Now what is the coefficient of t in this equation? It is omega. So v is equals to omega upon what is the coefficient of x? K. So v is equals to omega by k. You have also derived this by using omega upon v. What is omega in terms of nu? It is 2 pi nu upon v. Or you can write nu upon v as lambda. Why? Because v is equals to nu lambda. Or we can replace v by nu as lambda. So we have replaced nu by v as 1 by lambda. Fine. So it gives you 2 pi by lambda. And if you remember, I told you that this quantity represents the, what does it represents? The angular wave number or propagation constant k. Okay. So from here we have derived that omega by v is equals to k, which is, on rearranging, we'll get this equation, v is equals to omega by k. So in this way you can find out the wave velocity. Now moving on to particle velocity, as I have already told you that it is a velocity with which the particles of the medium vibrate about their mean position. So now let us proceed in manner to find out the particle velocity. Now what is the displacement reaction along positive x direction? You have seen in plane progressive harmonic wave that y x comma t is equal to a sine omega t minus kx. Okay, now take it as equation number 1 and differentiate this equation with respect to t. We can also differentiate this equation with respect to x, but we will do it later on to see what do we get. And here x is constant. Now, by differentiating, you know dy by dt will give you what? It will give you velocity. Now, this velocity, which I am denoting by capital V, gives you the particle velocity. Why? Because this displacement is a displacement of the particle. Is that clear? I have explained it to you earlier also. This represents the displacement of the particle, which is a function of x and t. Fine. That is why on differentiating y with respect to t, we get the particle velocity, which is equal to, now differentiate it. First of all, sine will give us cos omega t minus kx. Now, as we are differentiating with respect to t, so this will also get differentiated. Now, t gets differentiated and we are left with omega. So, this gives us omega a cos omega t minus kx. Now, let us mark this as equation number 2. I can also write this equation as omega a sine omega t minus kx plus pi by 2. Now, if you remember the trigonometric ratios in the quadrant, okay, so pi by 2 plus theta, sine pi by 2 plus theta is cos theta. Okay, so from here we have derived this. Sine pi by 2 plus theta is always cos theta. Is it clear? I think it is clear to you. Now mark this equation as equation number 3. Now from this equation, what all we can conclude? That this you already know, that the wave velocity, it remains constant, but the particle velocity, it changes simple harmonically with time, because we are talking about a plane progressive harmonic wave. We have used a displacement equation for plane progressive harmonic wave. So this shows us that particle velocity changes with respect to time. We have a component of time over here. Okay, also as you can see that we have displacement equation a sine omega t plus kx, but v, which is a velocity, we are getting it equal to omega a sine omega t minus kx plus pi by 2. This plus pi by 2 component means that a particle velocity, it lies ahead of the displacement in phase by pi by 2 radian. Okay, it is ahead of the displacement by pi by 2 radian. Fine. Is it clear to everybody? I have explained this to you already. Now next is, if we find the maximum particle velocity. Now maximum particle velocity will be equal to, or it is also known as velocity amplitude. Now it is equal to, let us say, we can represent it as omega naught. It is equal to omega a. Why? If this term becomes 1, yes, then only the particle velocity will be maximum. And when is sine maximum? Sine is maximum for 90 degrees. Sine 90 degree is 1, whereas cos 0 degree is 1. So sine 90 degree is equals to 1. So if this equation becomes, if omega t minus kx plus pi by 2 becomes 1, then we can say that this particle will have its maximum velocity. Okay, so this component will become 1, and we are only left with omega a. Now omega can be represented by 2 pi by capital T, which is the time period, into a. So from here we can say that the maximum particle velocity is 2 pi by t times into displacement amplitude a. Okay, now next. Now suppose if we differentiate equation number 1. Now we differentiate equation 1 with respect to x. Earlier we differentiated it with respect to t. Now we will differentiate it with respect to x. We will get dy by dx equals, now differentiated with respect to x. This is sine. It will give us cos omega t minus kx. And we have a already, and as we are differentiating with respect to x, so this component will also get differentiated, which will give us minus k. So dy by dx will be equals to minus ka cos omega t minus x. Now take equation number 2 and let us mark this as equation number 4. Take equation number 2 and equation number 4. Now by these equations, by equation 2 and 4, we get, if I divide these two equations, dy by dt by dy by dx, or dy by dt is equal to v. So if I write v by dy by dx is equal to what? V is equal to omega a cos omega t minus kx, whereas dy by dx is equal to minus ka cos omega t minus kx. Now from here, cos omega t minus kx component will get cancelled, and we are left with A also gets cancelled and we are left with minus omega by k. And we know from here, as you can see, omega by k is equal to what? It is equal to wave velocity v. So we can replace omega by k by wave velocity v. So from here we have derived that v, particle velocity, divided by dy by dx is equal to minus omega by k, which is equal to minus v. Therefore, we can also write that particle velocity is equal to minus of wave velocity into dy by dx. Now, what is dy by dx? dy by dx is the slope of displacement curve at that point at which the particle is lying. So from here we have also derived that particle velocity is equal to minus v, which is wave velocity, into dy by dx, which is the slope of displacement curve at that point.